Ladies and gentlemen, thank you for standing by. Welcome to the Cold-in-Place Recycling and Cold Central Plant Recycling webinar. At this time, all participants are in a listen-only mode. If you should require assistance during the call, please press star then 0. I would now like to turn the call over to your host, Jason Dietz. Please go ahead.
Thank you. Afternoon, everybody. I appreciate everybody's ability to join our webinar today. This is Federal Highway and Pavement Preservation and Recycling Alliance webinar series. And a little bit of background. Practicing preventive maintenance throughout the life of a pavement surface can extend its years and also dramatically reduce long-term costs. Cold-in-place recycling, cold-centric-place recycling, which we'll talk about today, goes a long way to achieve that end. Saves you money, helps the environment, and enjoy a long listing of other great benefits that will be discussed in our webinar today. Little background, there's some poll questions. Please take the time to answer them. They come in handy for us for future webinars, as well as questions. We encourage questions. Please enter your questions in the question box, and we'll share those questions and answers electronically following the webinar. If we don't get a chance to answer all the questions following the webinar today, we will provide those questions in a separate document for your information. Now let's get to our presenter for today. I'd like to introduce Jason Wolofsky. He started as a research engineer with Heritage Group back in 2008. Jason currently is the Director of Construction Materials Testing and Research. Currently, Jason is a member of the Board of Directors at the Asphalt Recycling and Reclaiming Association, or often referred to as ARA. Members of the Asphalt Institute Technical Advisory Committee and the Standing Committee of Transportation Research Board, AFK 30 Committee. Prior to joining Heritage, Jason was a quality control engineer for Granite Construction in Reno, Nevada. He earned his Bachelor of Science degree in Civil Engineering from the University of Toledo, and then earned his Master's degree in Civil Engineering from Auburn University at the National Center of Technology, with an emphasis at pavement design and bituminous material. Jason is a registered professional engineer in the state of Indiana. I'd like to now welcome Jason Wolofsky. Jason?
Thank you, Jason. I really appreciate that introduction. And again, thank you everyone for taking your afternoon to spend with us and learn more about these great tools, cold-in-place recycling and cold central plant recycling. So just looking at the poll results, thank you for filling these out. Looks like you know, most of us are beginners, which is good because this is intended to be an introductory type course, and some of us are somewhat familiar with these technologies, which is also great. So I'm really excited to see the background and experience there. So Jason, did you want to have any other comments on the polls, or are we ready to go ahead and get started?
Jason, I think we're ready to get started.
All right, great, thank you. So again, my name is Jason Wolofsky with the Heritage Research Group, and we're going to be talking today about cold-in-place and cold central plant recycling and how these are cost-effective engineered processes that give us performance on the roadway. And before we really get into the nuts and bolts of the processes, I just want us to take a couple minutes just to think about sustainability and pavement construction in general. Reclaimed asphalt pavement is a very valuable commodity. Ever since the advent of the milling machine in the 70s, we've been, trying to find ways to reuse asphalt. And, as we develop more and more education and technology of how to reuse these, asphalt pavement is the most recycled material in the world. And there are opportunities where we can reuse it in hot mix asphalt and replace virgin material, which is an excellent use for RAP. There are other ways that, folks use RAP. I see folks use it as shoulder materials or fill materials or I even see or hear stories how people use it in a landfill, and we're not really capturing or maximizing the value of that reclaimed asphalt pavement when we, use it like that. So, thinking about sustainability and all the materials we use to build our roadway networks, I think about how do we create a need for, continuing to develop and build growing, pavement networks and programs, and trying to reuse a lot of the materials that we've already invested in from an agency perspective. I feel like we all have this responsibility. I feel like it is to leave things in a better place than what we found it, and I feel like when we can take materials and find a new home for them, whether it's wrap or other materials, and create less demand on virgin materials, I feel like we're doing the right thing. But although it might have significant environmental impact, we also have to be mindful of cost. And we have to be mindful of performance, because if we use recycled materials and they don't show necessarily a cost benefit, or we have a performance issue, then it's not really a great solution. And today what we're going to talk about is how these pavement recycling tools, in particular, I'm going to mention a little bit about the cold processes, of how they're used and how they consume less natural resources, virgin materials, how they are all proven construction methods, engineering processes with engineered technologies. So I have a note here, roadresource.org. This is a great tool for everyone to get more information, not only on these recycling treatments, but other pavement treatments, focused from the PPRA perspective, a really great tool, and we're gonna dive into this. So poll question number 1, in-place asphalt pavement recycling can reduce construction greenhouse gases as compared to conventional mill and fill strategies by how much? Just curious what everyone thinks from an eco-friendly benefit for using recycled materials over conventional methods. We'll give it a couple minutes so everybody can vote. Still see some votes coming in. A lot of our teammates or a lot of our participants, 30 to 40% being the leading one right now, followed by greater than 50%. Some of us are in the 20%. So final results, survey says everyone was thinking that 30 to 40% savings. Well, in all actuality, data and information out there suggests that in-place recycling can reduce greenhouse gases up to greater than 50% on projects compared to traditional rehab technologies. So let's look at the other benefit. Let's think about and look at cost. So poll question number 2, the cost of in-place recycling can be how much compared to the cost of conventional rehabilitation strategies? We're seeing a lot of us are thinking that 20 to 40% is the leading vote getter right now, followed by 40 to 60%. A few of us are assuming greater than 70%. A couple more votes trickling in. Poll is closed, and the most popular answer was 20 to 40% less than the cost of conventional rehabilitation strategies. And in all actuality, most of the information and data collected and published out there suggests that 40 to 60% cost reduction is realized by agencies. And again, that's very project and location specific. But we'll have some of that examples later on today to show some cost savings. So let's discuss the presentation objectives. So we're going to walk through and understand the cold in place recycle, the CIR, and the cold central plant recycle, or CCPR processes. We're going to discuss the equipment that would be typical for these construction techniques. We're going to have some discussion around the materials that are used to make these cold mixtures. We're going to walk through some project selection guidelines and construction considerations for be cognizant of when we're out there building these types of pavements. We're going to walk through some example projects. We're going to show some pictures of these projects being constructed and share some data that some of our DOT colleagues have to share with the world. And then at the end, we're going to identify some additional learning tools for us to gain more knowledge on these rehab technologies. So again, the three cold pavement recycling technologies, processes that are common are full depth reclamation. And I just mentioned this because it's very, it gets tied together with the CIR. The FDR typically is much deeper, it's 5 to 12 inches. We're getting into the aggregate bases or subgrades depending on what problem the pavement exists. And oftentimes FDR is used by agencies as an alternate treatment to full reconstruction. Now in the middle we have the cold in place recycle, which typically is a cutting depth of 3 to 5 inches. And that wrap is stabilized with an emulsified or foamed asphalt. And agencies typically use the CIR as an alternate to deeper mill and fill type projects where we have to get deeper into the pavement to address certain distresses, or in opportunities where you have a mill and fill candidate that may have a lot of partial depth patching in the asphalt pavements that need alleviated. So CIR, we're typically staying in the asphalt pavement layer. We're not touching the aggregate bases or subgrades per se, although if you get in the aggregate base a little bit, that's okay with the technology. The third treatment is the cold central plant recycle. Very similar to CIR, as we're going to find out through this presentation today, but in this process, the wrap is actually removed from the roadway and is actually mixed and processed more often than not in a portable pug mill unit, so it can stay close to the project site, reducing the amount of trucking journeys and distances. Similar to the CIR, we're going to use an emulsified asphalt or a foam asphalt. And agencies typically use the CCPR as a structural base layer. So these recycle treatments, if we were looking at an AASHTO 93 design guide, some agencies suggest that they're up to 0.4 based on some research. Others use typically a 0.3 A1 coefficient, so much stronger than our aggregate bases that we're more accustomed to designing with, and getting awfully close to the design strength of hot mix asphalt as well. So moving on to the next poll question, just wondering, for our agency folks out there, my agency has used the following treatments in our pavement network. Have we used FDR, CIR, central plant, 2 of the 3, all 3, or we have not used these treatments yet? Wow, I'm really excited to see a lot of our participants have actually used all 3 of these treatments. That's amazing. We'll give it a few more seconds. So many of us have used the FDR. 33 have responded using the FDR. 32 have used the cold in place recycle. Central plant, only 6 of us have used it. A few of us have used 2 of the 3. 25 have used all 3 treatments. And then a couple of us, 16 of us, have not tried these technologies yet. So hopefully for those that are looking for a lot more information on how to use these, I intend this presentation to help with a lot of that. So help build some comfort level and information to share. Let's talk about cold-in-place recycling and how it works. So again, we're going to treat 3 to 5 inches of that existing pavement. So think about pavements where that distress is a little deeper than just on the surface. We're getting deeper into it, and that milling machine is going to go through, take that wrap off. We're going to add a stabilizer to it, and we're going to pave it right back in place on top of the existing pavement without disturbing underlying layers. And CIR candidates, they're typically ideal to address issues like raveling, reflective cracking into the asphalt pavement, including composite-type pavements. Can help with edge and block cracking, age-related cracking, potholes. Can also help with stripping and localized layers. So as long as you can touch and grab it and get that stripped layer and get it mixed up throughout the rest of the pavement, we can remix that material and lay it back down in place for a good performing structural layer. So this is an example of a single unit recycling train. And it's pretty awesome the first time you see it, how you're so accustomed with seeing material getting removed from the roadway, and we bring a bunch of materials, come back, and we lay virgin materials in conventional methodologies. Well, we do that in this process. We eliminate all the trucking. It gets milled up, gets added in the stabilizer, gets added in that recycler, and it goes right back into the paver and gets laid down in place. We have some additional equipment out in front of that milling machine. We have a water tanker up front. Typically that water is added to help, we like to add water to the millings because the water helps reduce the surface tension on the wrap and helps with the mixing and the coating of our stabilizing agents. And then we have our stabilizer tanker. In this case, it's an emulsion tanker delivering emulsion into that milling machine. And it goes straight into a standard HMA paver in this case. And there's a lot of different types of CIR equipment available, and for the sake of this presentation, I have photographs of 3. There's typically a multi-unit recycler. Here's in the middle, there's another single-unit CIR recycler, except in this case it's a windrow where they pick up machine in front of the paver. And then the third picture is a single-unit recycler that actually has a screed attached to the recycling unit tied to it, and it eliminates the need for the paver. And there's also some other units, including a 2-unit train where it's a milling machine, picks it up, screens the material, mixes it, and puts it into the paver. And I guess the important part is a specification can be written so that any type of cold-in-place recycling machine can show up and successfully perform a job. As with any types of machine, there might be some advantages with one over the other, but I think what I've found over the years is all these types of equipment can successfully build projects as long as the logistics are understood and the expectations are really understood. Self-propelled milling machines with accurate spray pumps so that we are properly adding the stabilizer to the wrap milling, and then having the necessary lay-down equipment to successfully lay down a smooth mat to the correct lines and cross slopes. And here's an example of a CIR mat coming out of the back of a HMA screed, and you can see that they're laying a CIR mat adjacent to a previously laid mat. So just kind of an idea of what these materials look like. It's definitely not hot mix asphalt. It doesn't have that high black sheen type appearance to it like we are accustomed to seeing with our HMA mixtures. It'll come out looking dark with some of the moisture that we have, and as it cures out and develops strength, you can kind of see that change colors a little bit. But typically we use HMA paving equipment, heavy-duty pavers, good production, hold line and cross slope. We can successfully place and lay these types of materials. And compaction is also relatively similar to hot mix asphalt. Typically we see 2 to 3 rollers on a CIR job. Usually we start off with a double steel drum roller, vibratory compaction mode to get initial density in these materials, and then nearly all the specifications I'm familiar with also require a rubber tire roller. And the rubber tire roller does a really effective job of kneading compaction. With these materials being cold, the rubber tire helps orient the wrap particles and build really good density, and in turn builds really good strength in these CIR layers. And oftentimes we have another double drum steel roller to finish the mat after the rubber tire. But typically we see 2 to 3 rollers on these jobs to get sufficient density and in turn performance on these recycle type mixtures. And here's an example of a CIR mat, a fresh CIR mat adjacent to one that had been laid a couple of days earlier. Again, just to get a visual idea of what the material looks like. So the mat on the left was just placed when the picture was taken and is in the process of being compacted. And you can see it's a little bit darker as the emulsion and the moisture are beginning to escape from the pavement. And you can look at the adjacent lane. It's a little grayer, it's a little duller. While the moisture that's introduced in both the emulsion and the milling process is getting out, and we're seeing what a typical mat might look like. It's good to note that cold recycle, FBR, CIR, central plant, it does require a wearing surface. These materials typically have a higher void content than we typically would see with our HMA pavements. And when I say that, I don't want to paint the picture that it looks like an open graded friction course or a permeable drainage layer. It still looks like a tight mix, but we have a lot more smaller voids in it, which means that it does have the ability to take on moisture, and we need the ability for it to release that moisture as well before we put our surface on top of it. Highly recommended to do that before winter and ice and freezing in our northern climates, and depending on the traffic volume, we can use a number of different types of surface treatments successfully on recycle projects. So on our higher volume, interstate, state highways, we'll see single lift HMAs or multiple lifts of hot mix asphalt. But also on some of our township roads or our county highways, we'll see agencies successfully use cape seals or a double chip seal or a single chip seal layer, depending on the expected traffic loading and the pavement design with that project. So at the end of the day, it's important to get the surface on these recycle layers and to ensure that we have the right type of surface based on the traffic that pavement's going to see. So we'll take a look at the next poll question, and I'm just curious, on your last recycling project, what kind of surface was placed on top of it? Was it a single lift HMA, a multiple lift HMA? Do we use a cape seal, chip seal, or do we use some other type of treatment on top of that recycle layer? We'll leave the poll open for a few seconds here. So the majority of us have used the single lift hot mix asphalt on our last recycle project. Some of us have actually used a cape seal, which is great. And some of us have actually said other, so I'm curious to hear what other might be in this situation. So for the majority, we've used hot mix, whether single or multiple, but we also have some experience using the preservation treatments as services. So that's awesome. That's great. So the recycle processes have a couple of main components that comprise the materials, and the first one being the reclaimed asphalt pavement, and for CIR it's the existing HMA. We add a recycling agent, stabilizing agent, and that's typically in the 2 to 3% range by the dry weight of the aggregate. And in the CIR application, we're using a emulsified asphalt, or a lot of us are using engineered emulsions, or emulsions that are formulated and designed to meet, project requirements based on strength and cohesion developments. Other agencies and contractors are using a foamed asphalt system, which acts as a stabilizing agent and gets good strength and performance in the CIR. Other options include having some additives included in the recycle process, and sometimes we'll add a small amount, around 1% Portland cement, just to help with strength and stability and rate of strength development. Other agencies and contractors have successfully used quicklime or hydrated lime to help with adhesion. Some folks have used lime slurry, also to help with adhesion properties of the mixtures. Some folks use corrective aggregate, and corrective aggregate can be used in a number of different ways. It can be, used to help add and bring better aggregate into that mix for strength performances. We can use corrective aggregate, or we can bring in additional wrap if we need to increase the volume of material we need to create the new layer that we want. So, a lot of times in the case where we're widening a narrow pavement, we can add aggregate on top of the existing pavement, trench out the existing shoulder, add material, mix it in the milling machine, and pave it wider, and widen the existing pavement with a new structural base layer. I mentioned earlier, we're always going to add a little bit of water in these processes, whether it's added for the milling process, or in the case of foamed asphalt, we're going to add water to get the asphalt to foam, to help with the mixing, and to help with the workability of the material as well. So moving on, let's talk about some things to consider when we're planning a CIR project. And I really like this picture because this is one of the first projects I've been involved with way back in 2012. There's a lot to think about when you're looking at a pavement like this and how I'm going to fix it, recycle it, and get the right surface treatment on top. So just some things considerations to think about. And number one is, where am I going to use it? And I think recycling technologies have this perception that, they've successfully been used on county highways and township roads and low volume roads, but over time, we're seeing applications where they're used on interstates, and the folks at, the Virginia Transportation Research Council, working with Dr. Brian Diefendorfer, has done a really great job of sharing their knowledge and experience of using central plant and CIR on their interstates in Virginia. We've seen projects at airports. A number of state highways have been recycled using the CIR technology. I mentioned earlier that we see this technology used on a lot of composite pavements. It can be used with curb and gutter with some additional planning on elevation reveal for the ensuing overlay. And we have successfully seen it used and applied in both urban and rural type settings. And the first part is an accurate pavement assessment, and more or less words, it's really saying, what do we currently have to work with here, and how do we identify that the pavement that we have is a good candidate for this process? Because at the end of the day, the engineering process really involves identifying the right road and pairing it up with the right treatment to get that desired performance. And ways that we can do that is we can go out and take cores of the existing pavement, you get an idea of pavement thickness, pavement consistency. Another tool that folks are using is ground penetrating radar to help classify and understand their pavement structure. That's important to understand the traffic counts and what kind of expected traffic that pavement's going to understand, and that's really going to help us identify the proper overlay or the thickness of the hot mix that's going to go on top. It's super important to understand the condition, the strength of our subbase and subgrade layers. The picture I show here, there's a drainage issue, there's a subgrade issue because of that, and it's important that the bases and the subgrades that we build these CIR and cold central plant layers are on top of are steady enough so that we can apply that heavy-duty compaction with our double-dome steel rollers and our rubber tire roller to build good sufficient density. That's always helpful to have construction records, understanding the previous treatments, taking a look and see, are we incorporating chip seals, are we going to encounter paving fabric, and understanding what types of asphalt mixtures are going to be hiding out in that pavement so we can get a better idea of whether or not these pavements are good candidates for recycling. In the case of paving fabric, I've seen a lot of contractors successfully recycle pavements with fabrics. It's just having a knowledge and understanding of it up front so that they can plan for it is important. There are always areas of concerns when we're planning any type of project, and the first one that I get real anxious about when looking at a road is understanding the subgrade of the pavement. Widespread subgrade failures, CIR might not be the best treatment for. I mentioned earlier that we need to have a good solid base to build density against. If we have localized areas, we might have the opportunity to go ahead and treat the subgrade problems, strength issues, drainage issues ahead of the CIR and then come in and recycle through those patches that we have. And in this case of the picture, you can kind of see that, we're recycling this pavement, and right there on that shoulder, we had a soft spot that the agency went ahead, dug out the soft subgrade, replaced with aggregate base, filled it in with temporary HMA. The CIR process will go through that patch, eliminate those seams so that we don't have a potential construction joint reflecting through the HMA once the CIR is done. It's always good to understand the rutting if it does exist on a pavement. Is it from the base or the subgrade? If we've got severe failures in the lower layers of the pavement, CIR might not be the best treatment for that because we're not really fixing the problem. In other cases I've seen where we get a lot of the shear rutting in the existing HMA pavement, and that's another issue to be concerned about because we're gonna take that mix and we're gonna crush it down, recycle it, and put it back together. It might be very important and very valuable to understand and to plan on bringing some corrective aggregate or some additional materials in there to help alleviate a future recurring shear rutting problem with that potential CIR mixture. Drainage is always an area of concern as it's related not only to recycling but any pavements. And this reminds me one time a pavement in northern Indiana I came across one time, and before we go and invest the time and the effort to recycle a pavement, we should ensure that the drainage scenario is proper for performance. In some cases I've seen agencies, install under drains. Other agencies, rural agencies, it's a lot of improved ditch work to help make sure that the water's getting out of the pavement. The coring process also can help us identify if there's insufficient structure there to recycle. If there's not enough pavement there to recycle, we can always perhaps add material up front, the term of corrective aggregate or wrap, and build a thicker, stabilized layer for our ensuing overlay. So all those areas are things that it's really important to help build good projects. We can learn a lot from the distresses and the cores. It tells us about the materials, if things have been stripping, if we have some poor aggregate in there, if we have some under-asphalted materials, it can help set the tone of how to design a successful project later on with materials and construction processes. I think it's also important for agencies to understand and to work with their local recycling contractors on any pavement load restrictions that may exist. The equipment that I showed is pretty heavy equipment. Understanding if there's any bridge load capacity issues or base or subgrade strength issues, we don't want that those machines popping through and getting into the subgrade. So it's really important that during the planning stages that there's a way for the equipment to get in and out of the project without any bridge restrictions, and to make sure that we have that foundation to support the equipment that will be building the pavement. Profile and crossload corrections is always an interesting topic. I feel like we get these roadways sometimes that they just kind of grow. Crosslope grows, or the quarter pound grows as we kind of traffic that pavement, especially a lot of our farm to market roads. You kind of get that parabolic curve in some pavements, and that's really hard to address with a straight line milling piece of equipment, and to anticipate that we're going to be able to take something that, in the case of this pavement, where it's maybe 7% crosslope, and try to get something more desirable like a 1.5 or 2%. So it's important to really consider some different tools up front to say, how can I set the table, if you will, so that the recycling process can help me achieve that crosslope that's desired for my final pavement. Because the recycle process with the milling, typically we might be able to achieve plus or minus 0.5% crosslope correction. So some alternatives to think about: you could pre-mill on that pavement, so you can actually have a milling operation come up and shape that pavement. You could also use some 3D milling. After the fact, you can do some wedge and level to help correct some spots that might need a little extra attention. And if it's really bad, it might not be the best treatment. So, the FDR process might be a better treatment, for example, if there's a significant amount of crosslope issues that need corrected. It's one of those things that can be corrected with the two-step FDR process. Successful projects are always tied together with really good specifications and really good quantities up front, because in my opinion that really helps us, everybody, get on the same page of what the expectations are, and that a lot of the homework's been done up front for materials and payment and the process in general. It really helps to have an idea on quantities. For the contractor's perspective, it really helps with planning when we're bringing out tankers of foamed asphalt or emulsion, understand if additives are optional or required or needed. Really helps with the bidding process and understand the cost up front, that what the treatment's going to take. It's important that in those specifications, the contractors fully understand what the mix requirements are, quality control plans, and what is expected to be tested in the field to ensure that product is being constructed accurately. I always like to have an idea of what a subgrade repair contingency is, just in the case that you hit a soft spot. How are we going to fix it? Are we going to dig it out and fill it with stone and HMA, for example? And another tool that I think it's been super helpful here in the state of Indiana, as we're learning how to build more of these across our state network, is just-in-time training. Just-in-time training is a small presentation where we get all the stakeholders together before the process, so our inspectors, our construction engineers, our materials engineers, the contractors, the QC personnel, and we walk through what the process will look like. Talk about the results of the mix design, talk about the equipment, talk about contingency if certain things occur in the field. And it really helps a lot of our inspectors that may not have had the opportunity to see these processes yet. So it gives them a chance to kind of see what the materials are going to look like, what the equipment's going to look like, an idea on what the testing is going to be needed to ensure that we're getting good construction out in the field. So just some questions to think about as we're putting projects together. And do we have a good understanding of the distress on the pavement and why it's happening? You know, CIR, the right treatment for it. You know, thinking about, did we do a good analysis of the existing roadway to understand what's there? It's always good to have a good understanding of the pavement to avoid any surprises, you know, during construction. Thinking about logistics, timing, the surface overlay, the application, the timing of the bid, the timing of construction. These are all items that are really helpful to ensure good projects. Are the specifications written so that the material being constructed with top quality materials that are available for these processes? Additives if necessary, and the quality control plan to ensure that good workmanship is also accompanying those good materials for performance. It's always good to think about and verifying, you know, does the pavement design with this treatment, is it going to be able to meet the future traffic expectations for the roadways? So just some questions to think about as you put the opportunity to put a project like this together. So adding in a poll question, just wondering, what kind of challenges exist to setting up a CIR Cold Central plant project for my agency? I'm just curious what challenges currently exist out there for our teammates as they try to implement these types of projects. So we'll let the poll question go up for a few seconds. I'm having trouble seeing the poll questions, Jason. There we go. So as the results are coming in, we see a lot of the challenges are related to specification development, project selection experience, contractor availability, and then agency comfort level. And I think a lot of that is able to be overcome with you know, the additional information that's coming out from AASHTO, FHWA, and CHRP as it's related to helping folks put together specifications, and we're going to talk about that. Project selection experience, there are a number of tools available to help us identify good candidates. I would advise to check out the Asphalt Reclaiming Recycling Association websites to understand which contractors are available in your area that perform this type of work. So we actually have a Find a Member section, and you can kind of see who the contractors are that come to a given area to do these types of treatments. And comfort level is very real, and I understand and I have appreciation that you know, it's a responsibility to use taxpayer money responsibly to build good pavements, and I think it takes that level of comfort to invest in these technologies and getting the opportunity to see projects from adjacent agencies or other agencies and hearing how they're being built and seeing performance hopefully would help build that comfort level to make that investment. So I appreciate everybody's feedback on that poll question, so thank you. I'm trying to move the poll question out of the way. Jason, can you help me with that, please?
Should be out of the way already.
All right. Maybe my computer's a little slow. So we'll talk next about the CIR construction process and things to look at and be mindful of as we build these types of pavements. Jason, I need some help here. I got this question box still hiding up here. I apologize, everyone.
Right. Right now, currently, we have your CIR construction photo showing.
Okay.
Are you still seeing a poll question?
Yeah, I still see the poll question.
Okay. Not sure what's happening there.
It's all right. I'll figure it out. I apologize, everybody. We got a little technical difficulty. So just a few things to think about as we are building these types of processes, and we'll talk about the construction process. So we're on slide 31. And the first thing we want to talk about is pavement sampling for a mixed design. So once a contractor or once a project identified, advertised, successfully bid, typically the first step in the process is the contractor comes to the pavement and samples that project so that the contractor can put together a mixed design for the recycle treatment. And it's important that, you know, proper sampling is performed not only in terms of volume. Typically, 400 pounds of wrap is required to successfully get through a mixed design. But we want to make sure that samples are being collected, you know, and all lanes being recycled. We want to make sure that we're taking samples across the width of the entire pavement. There's a lot of times where, you know, we see pavements that have been widened over time. So, you know, the outside 3 foot of a pavement might be different than the inside, 20 feet, if you will, where, you know, that pavement has been widened over time with a different type of material, or the shoulders were constructed with a different type of material. And it's important to include those if they're designed to be in the recycling process as well. It's also another opportunity for the contractor to take a look at and evaluate the base and the subgrade issues. Typically what we'll use is a dynamic cone penetrometer. Take a look underneath the asphalt pavement just to get an idea if we see any soft spots or potential issues underlying the pavement. So moving on, poll question number 6. What is the recommended spacing of field sampling and testing? 1 core per total job, multiple cores in one location, multiple locations across the entire pavement. They adjust pending on unique areas that would otherwise be missed, staggering cores across the entire section of pavement. And I think in this question, there might be more than one right answer. All right, we'll let it go for a couple more seconds. So agreed, we want to make sure that we take multiple locations across the entire pavement. We've seen projects, unfortunately, where we take one large sample out of the pavement. We try to characterize the material off one location, and that's a little dangerous, especially if we have a change in materials throughout the length of a project. It's always recommended to take a look and take a sample if something looks a little different. Not only might it be a material difference, but it could be a change in base, subgrade, or drainage-related issue. And we always recommended to stagger cores across the entire section of the pavement. All right. So moving on to CIR mixed design testing requirements, they're a little bit different than what we're typically accustomed to with hot mix asphalt, where in hot mix asphalt we typically design a specific air void content based on a VMA requirement that helps us dictate and set what kind of asphalt content we're going to add to a mixture. Whereas with in-place recycling technologies, the material that we have to work with is based on what's there. So the contractor really doesn't have the ability to change the aggregate structure or the source of it other than what he can control with the milling machine. So typically, the mix design requires the contractor and his lab to take the field samples, take the cores. We're going to process that wrap to a gradation and a shape and a strength and a texture that we would anticipate after the milling process. And we would then take those millings and we're going to add different dosages of stabilizers and mix additives to more or less see different performance requirements. We're going to look for strength in terms of Marshall stability or indirect tensile strength testing. That's generally an either or in specifications, just to see that that mix is going to be resistant to rutting. And in the case of the Marshall stability test, we're looking for 1,250 pounds of a 4-inch pill at 40°C, which is the elevated test temperature. Or we're looking for an ITS result greater than 45 psi at room temperature. The next parameter that's typically looked at is the adhesion. So, in other words, how well is the new glue sticking to the old glue, and how is that going to respond over time as moisture tries to damage that bond and that relationship? So similar to how we design asphalt pavements with a retained Marshall stability or a retained ITS, we will condition a dry set of pills in the lab, vacuum saturate with moisture, and then try to see what the effect of the moisture damage is on the strength of the mix. And typically with both the stability and the ITS testing, we're looking for 70% strength. We also look for the rate of strength development, so the strength gain. And the raveling test is used to do that. We're looking for 2% loss in the raveling test. And here's some example of CIR mix design tools. So there are specifications developed through AASHTO for mix design process, so AASHTO PP86 and PP94. It's always helpful to have an accredited and experienced lab in these processes to put reliable mixtures together. And those labs generally have a collection of saws, lab crushers, typically a gyratory compactor. A working foamer is needed if we're doing a foamed asphalt design because it simulates that foaming process in the lab that happens in the milling machine. We need different mixing devices, curing ovens, Marshall presses. And here's an example of that raveling device. So it's a Hobart mixer that takes a partial cure sample around, and we want to look for mix loss over time. Once we get out in the field and everything's ready to go, it's always important to think about safety on the job site, particularly the maintenance of traffic, understanding where cars are coming in and out of and how they're going to get around the job site. In terms of foamed asphalt projects, it's really important everyone's cognizant that that is hot asphalt in those tankers when we're hooking up to the milling machine. Typically that stuff is greater than 320 degrees Fahrenheit. Always need to understand and respect the size and the speed of the equipment, and it's good for the contractor to have a spill plan in case there is a leak as they're transferring hoses, switching out tankers, and understanding how to respond to that in the case that it does happen. Traffic control goes along with safety. The safest projects are always closed and open to local traffic. With some projects that's not always doable. So It's important to understand the size and the width of the equipment as well as we're trying to put traffic in and around the construction crews. So, here's an example of a project where the CIR machines are going down the road and we're trying to use the inside shoulder to keep moving live traffic around the CIR operation. It's always a good rule of thumb to have a work zone 2 miles or less. The paving train moves against traffic. That prevents vehicles from stopping on a fresh mat as they wait for the flagger to let them go through. Flaggers are always needed. Pilot cars recommended if sight distance remains a problem, and always keep your head on a swivel out there because there's a lot of moving parts, rollers, tankers, water trucks, milling machines, live traffic. Weather considerations are important for these processes. It's important to have a minimum ambient temperature of 50 degrees in most cases to get the emulsion or the foamed asphalt to activate and stabilize the materials. If we have reduced temperatures, it can reduce the service life of the CIR because it doesn't have the ability to gain strength as that water is curing out of the emulsion. So it's important to be cognizant of when these are going to be built also. We should not do CIR during wet conditions or if rain is imminent. It's always good to do these during the daytime. Sunlight is best for curing, and recycling is recommended to be completed within 2 hours of sunset. Quality control, always good to have a good solid plan up front. First thing is establish a rolling pattern. Identify a target density. Generally with a nuclear gauge, we're going to do a growth curve and check a peak. Generally with these being 3 to 5 inches, we're going to use backscatter on the gauge. I've seen other folks use a wet proctor to set the big density number or target density, and then with the gauge we're going to have a typical requirement of 95 to 103% of that target density. We like to take gradations in the field to compare to the mixed design to ensure that we're going to have similar expected results to the mixed design in the field. We always want to check our material yields to make sure that the equipment is metering in the desired stabilizing and additive types. We always want to check the foaming characteristics if we're using foamed asphalt. We want to check the moisture content of the CIR prior to overlay. We don't want to trap moisture in that mix, and we want to make sure that it's not overly wet to create issues in the hot mix that's going on top of it. Be sure to expect those conditions to be met, and always ask for input from experienced QC personnel and contractors, because there's a lot of experience and there's a lot of conditions that we can overcome in the field with the right planning ahead of time. So I mentioned earlier base and subgrade repairs. For those issues or those isolated areas that can't be identified ahead of the CIR process, go ahead and come up with a plan to how to adjust that. Typically that's a moisture-related or yielding subgrade issue, and in this case the CIR is removed and replaced with an HMA patch after the subgrade had been repaired with an aggregate base. A little note on curing. So rolling traffic is helpful to help drive moisture out of the mixtures. Sunny and hot days will help accelerate that cure. And when it rains, it does kind of pause it and slow it down. So it's important to understand ambient conditions as that material wants to dry out and gain strength before we get it covered. Typical specifications are 2 to 3% or below in the CIR mat before we want to cover it, and we really don't want to apply those surface courses on top. For one, if we trap a bunch of moisture in, it might damage the CIR over time, and it can also impact the constructability of the hot mix on top. If there's a bunch of moisture that's hiding out in the CIR layer, we put that hot asphalt on top of it, that moisture can wick up and create some constructability and some tenderness issues with that hot mix asphalt. So it's really important as part of the quality control that we make sure that moisture is out of that pavement. And again, key for recycle projects, right road, right time, right treatment. and it starts with the project selection. Utilize that engineered process with the scoping, the proper pavement design. Think about the right recycling agent for your project. Get a good mix design done, and make sure that we're getting the right quality control in the field. So would like to do a little project walkthrough. And the project I'd like to share is a project that was constructed in the state of West Virginia back in 2015. It was a 4-lane divided highway, high-speed route, pretty rough shape. It was a composite pavement, asphalt on top of concrete. We were looking at 64,000 square yards of CIR that was going to get covered with a 2-inch HMA surface. And here's an idea of what Ravenswood State Route 2 looked like prior to treatment. So a lot of distress, age distress, a lot of cracking. Again, this was a composite pavement, so none of this was all attributed in the top layers of the HMA. And moving on, another shot of the road there, and you can kind of see some of the distress that we saw in the cores that were collected. So a lot of cracking throughout the top 4 inches that were going to be targeted with to be treated with the CIR. Maybe some potential stripping issues in some of the second and third layer. So just a couple shots of the process. So we could see that the compaction of the CIR is happening behind the paver. And I would like for everyone to note the shoulder that's tied adjacent to it. The shoulder wasn't treated in this case. And shoulders are real tricky in the sense that I mentioned earlier the CIR has a higher air void content than HMA, and in this case a really old HMA pavement. Think about shoulders and how that might retain moisture if there's a rain event. I always recommend agencies to think about shoulders because we really don't want to create a bathtub if there's a significant rainfall, and we have to worry about that moisture getting out and extending the curing time, if you will, before that HMA overlay can go on file. Here's another picture of the completed CIR mat. Again, you can kind of see the inside shoulder there getting constructed. So shot of the mat going back, completed pavement. And we're always curious about, well, it's a recycled pavement. How's it going to respond to traffic in real time after compaction? And the guys at West Virginia DOT, particularly Travis Wallbach, shared these photos with us in other presentations. And I love this picture of the semi coming across, turning across this mat at an intersection in this highway. And the neat thing is you can kind of see over time that intersection was definitely, watched during the process, and that slow turning, shoving truck traffic didn't really impact the mat. You might see the tire marks on the top, and you could see some roll off to the side at the cold joint, but that mat really didn't distort, rub, or shove, after traffic. You can kind of see another shot of the emulsion tanker as it's leaving the project. And those wheels as they turn, they kind of shove laterally a little bit also. And we didn't have any issues with the roadway there. So how does it look now? So this was a picture taken back in 2018. Roadway looks pretty good. No reflective cracking coming back up through the concrete yet. Again, that was only after 3 years. Another shot of what that intersection looks like. So no rutting from the slow stop truck traffic there at that intersection. Took another shot of that roadway in March of 19 after another winter. Again, we didn't see any reflective cracking coming back after 4 years. Now, if we take a look at it now, so this picture was shared with me by the West Virginia guys a few weeks ago, and that pavement's in really good shape, and it's not showing any rutting or appreciable cracking at all. So how do you measure performance? And one way, we often do that is ride. So the International Roughness Index is a measure of smoothness, and typically a higher number represents a really rough ride where a lower number is smooth. So the guys at West Virginia shared this really neat data where, we did a 170 before the CIR. It was actually measured during the CIR. It dropped it down to a 115. After the HMA was placed, it was below 70 at 67. And today, as we continue to measure, ride on that pavement, it's still in the low 60s. So in terms of ride and smoothness, it's performing quite well. So moving on, poll question number 7, just curious, what is the maximum allowable RAP in your state HMA mixtures? Just curious what everybody can put into their HMA in terms of RAP. Give it a few seconds. Leading candidate 10 to 25%. Some folks are using 25 to 40. That last one should be greater than 40%. Some folks do not allow RAP in HMA mixtures. Interesting. We'll give that a couple more seconds. So in general, 10 to 25% RAP is generally accepted into hot mix asphalt. So as we take RAP off of projects, only 75 to 90% of it's going potentially right back in. So just want to think about where does all that extra RAP go and where can we find really useful homes for that RAP, because I think it's definitely an opportunity for us to think about RAP management and how we reuse a lot of the material that we've already been invested in. So cold central plant recycling is the next treatment we're going to talk about. And it's a neat treatment in the sense that we're going to take a distressed asphalt pavement and we're going to take it off, because sometimes we have to get below that asphalt pavement to see what's going on and to fix it. It could be a base issue, it could be concrete joint repairs, it could be a base stabilization. And what we're going to do is we're going to take that asphalt pavement off the roadway, we're going to stockpile it at a nearby location, we can treat it and place it back on the roadway after we fix that problem below the asphalt pavement. And here's an example of a cold central plant example layout. So this is an example of a portable pug mill system that can be brought in close to the project site to process, to coat that RAP. You can kind of see it's getting loaded into the bin there, goes through the pug mill process, comes out, it's getting added with a recycling agent. Similar to CIR, we're going to be using emulsified asphalt or foamed asphalt. Goes into the pug where it's mixing the RAP with that stabilizing agent and comes out and gets stockpiled as a new cold central plant material, all cold. So we're not adding any heat in this process. And where does RAP for central plant come from? Well, it can come from an existing RAP source. As long as that RAP source is free of deleterious material and has a good known consistency, a proper design can be tied to that RAP pile, and it can be used as a structural base layer on projects. It can come from a current roadway where we're going to take that RAP, we're going to send it down the street for shipping and handling, we're going to fix problems below it and bring it back and lay it back down as a base layer. Or we could take it from one roadway and use it as a structural layer on another. It can be successfully placed on aggregate base layers. We see a lot of local agencies here in the state of Indiana and across the Midwest that are upgrading gravel roadways to hard surfaces using cold central plant type materials. We see it on stabilized bases, particularly cement FDR treated subgrades that needed some foundation improvement. We've seen double layer of recycles on top of each other. In the case of IDOT District 6 just did a pretty neat project where they used cold central plant and a double lift application to replace some shoulders. And we can place it on top of existing pavement if we need to add structure. And it's really similar to the cold in place process, except we had this shipping and handling where we're going to handle the material off the pug mill, load it into a truck, and deliver it on site. And with these materials, I think it's good to have kind of a window associated with workability. So it's really important for the contractor and the material supplier and the agency all to get up front about where that location is going to be so that that material can be mixed and processed and hauled to the site with enough workability to get through the paver and to build density in that mat. When we think about the other similarities to CIR, we spent a lot of time talking about the construction process, the laydown on the equipment, and it's very, very similar. Similar paver and roller requirements, mixed design and QC, our requirements are very similar in these processes. And the pavement performance also is pretty typical since we're using a lot of the same types of materials at very similar application rates. So I'd like to walk through a pretty neat project that was constructed here in the state of Indiana back in 2018. And it's Indiana State Route 101 up near Fort Wayne, Indiana. And it was an 8-mile project in length. The major collector near the Fort Wayne area. We had HMA over some trouble subgrade aggregate base. And it was also a pretty narrow road, so widening was one of the desired outcomes for any reconstruction or construction process. So as the state was evaluating the roadway, there was a lot of thermal cracking associated with this roadway from time. Again, looking at smoothness, this was a 153, so this was a pretty rough ride, and about 30% of it was deemed poor quality based on their pavement management system. And the lack of the shoulders really drove the state of Indiana to want to think about widening this pavement from a safety perspective. And I really appreciate Nick Kazenza for letting me use the slides that I used last year at the Aero Technical Conference to help tell this story. But really goes to show what kind of problem this pavement had. Little note on the course. So it did have some delamination issues both with the surface treatment and within the cores. There was some asphalt stripping from moisture infiltration and a lot of cracking in those lower HMA layers. So this is a neat point in the Indiana DOT's knowledge and experience with recycling. They were writing specifications for CIR and FDR, and I think this project came up, and it was, well, we really want to recycle the asphalt, but we know we need to get into the subgrade. And that's when we started talking and looking at the stuff that was going on with the state of Virginia and their Cold Central Plant recycling program. And it dawned on, you know, the programmers and a lot of the engineers at the state of, hey, why don't we try this here? And we can couple the FDR technology with the Cold Central Plant technology. So the idea was to take that existing 20-foot width pavement, we're going to take the existing asphalt off, we're going to widen that base, and then we're going to widen the base to 26 foot with the FDR process. We're going to pave on top 6 inches with the central plant recycling, and then we're going to cover that with a 2-inch HMA surface. So here's some shots of the project. You can see that they milled the 8 inches of the existing asphalt pavement off the roadway. We hauled and stockpiled that to a central location that was within 10 miles of the project. I think the nearest HMA plant was 22 miles from the project. They took that wrap, and the processing required that wrap to be crushed to 1 1/4 minus. Here's a look at some of the FDR operation. It followed the recurring special provision INDOT had at the time for cement FDR. They used 5% cement in the design, and all utility work, pipe crossings was performed before the FDR process, which was really important. And just some interesting statistics about the central plant construction. At the time, it was a recurring special provision 417 in that spec book. The mix design called for 2.5% engineered emulsion, which was added to the pug mill that I'd shown a few slides ago. It was laid down by a local HMA contractor to the Fort Wayne area, and 37,000 tons of that cold central plant mix was produced and laid in a period of 16 days. On average, that plant and that crew averaged about 2,300 tons per day, and that plant was clipping about 300 tons per hour. So there's always this perception that these technologies are super slow, but I think the contractor really showed that production can be pretty good on this type of material. When you're laying it 6 inches thick, the number of trucks you have to supply this project is critically important. So after the central plant was cured, the state of Indiana would do a profile mill or a scarification mill on all our recycled surfaces to help true out cross slope and to eliminate any bumps. The styrations also help with the bond between the recycle layer and the surface. And we put a single lift 2-inch NDOT 12.5 millimeter mix on top of that central plant. I really have to thank Bill Flora with NDOT for sharing this information with us at the 2020 Purdue Road School. You know, when NDOT was looking at the analysis, you know, their awarded cost for that 8.6 mile job was about $4.9 million, or $288,000 per lane mile. When they were doing the pavement replacement estimates, they came up with $692,000 per lane mile. The percent difference that they realized between those two, realized versus planned, was 58%. So there was a significant amount of cost savings realized by the state on this project. And it's always important to know, well, what did we get? Again, Nick Kazenza at ERA last year shared some of the pre-construction FWD testing, and it's important to see that, you know, the blue line, when the blue line gets above the dash line around the 12 on the y-axis, those are deflections that are a little bit too high for comfort level. And we also see down below the green line that's above the y-axis line, that's the subgrade deflection. So that's the information the department had up front to realize that that pavement needed somewhat of a structural improvement. After the FDR and the central plant construction, we can see that the blue line, except for a couple of outliers there, consistently below that 12.5 mils that the state's looking at. It's also important to know how much tighter that blue line got, so I think they built a much more consistent pavement than what they had by taking it all out, treating it, bringing it back with one continuous FDR-based stabilization process. They had a thick cold central plant recycle layer and a very good 2-inch HMA layer on top. And it's also good to note that the subgrade line is below, so you can see the significant improvement with the FDR cement stabilization also with this FWD results. That structural number jumped from what they had was a 3.7 to a 5.09 with the treatments. Here's a shot of the State Route 101 spring 2000, so a few months ago. That pavement has an IRI of 65.4, so that is definitely going to be a pavement that we continue to watch over time and better understand how these materials respond and how they're going to perform in a relatively harsh, wet, freeze environment with some significant rural truck traffic. So just thinking about the recycling data on this project alone, think about what was reused. We reused 10 inches of the existing base subgrade, which was 95% recycled with 5% cement. The cold central plant was 37,000 tons. We're adding 2.5% emulsion, so 97.5% of that 6-inch layer was all recycled. And our 2-inch HMA overlay also probably had 15 to 20% recycle in it. So we did a really nice job of reusing a lot of the materials that were already in place. that part of the pavement. It's a really neat story that we like to share about success story here in Indiana. So moving on, just some additional materials for everyone to understand, some additional tools that are out there. The basic asphalt recycling manual, it was updated in 2015, is a great tool. It was developed by FHWA working with ERA. Great tool with a lot of information with all the recycling technologies. There's a lot of work going on with specification development. I mentioned the AASHTO specs earlier on for the materials and the testing procedures. ERA has best practice construction guidelines and mixed design guidelines that are available for use to help develop specifications. Many DOTs have specifications that are available for reference that many successful projects have been constructed with. It's also of note that NCHRP 1443 is underway, where they are developing construction specification developments for CIR, full central plant processes. It's really exciting to see that we've invested a lot of national research in these technologies. NCHRP 951 came out a few years ago, but it's a great piece of work showing how these materials can be analyzed in a mechanistic empirical type format. 962 is in progress. It's a study where we're looking at rapid tests and specifications for QC tools for recycled pavements in particular. NCAT and NRRA have test sections at their sites that they're investigating, publishing data and information on. And I mentioned earlier the folks at Virginia Transportation Research Council and VDOT have done a lot of great work sharing their experiences with recycled pavements and how effective they've been for their state agencies. I mentioned roadresource.org earlier. Again, great tool, a lot of great information on the different recycling and pavement preservation treatments. I really like the success stories, so agencies can go there and see how other agencies have used these tools in pavement performance and how they've successfully been completed. There's a lot of good training courses out there and available. NHI courses and TC3 courses are also available for everyone to better understand how these things are constructed and built. Just some additional helpful links from FHWA. There's a checklist series for our on-site inspectors and tech briefs, white pages on how these treatments are completed. The National Center for Pavement Preservation also is a great resource for additional information. And another tool that I'm pretty fond of was our DOT here in Indiana actually put together a recycling treatment flowchart, so they could look at pavement conditions, based on assessments coming in and looking at the stresses and pavement type and subgrade strength. They create a flowchart to help them understand which direction they should go on treatments. And I've shared a link with everybody here to check that out. I think that's a really neat tool that our pavement designers are using to help identify good FDR, CIR, or FDR, CCPR type projects. The final thoughts, it's all about right road, right time, right treatment. Agencies can save money with these processes. They can save construction time. They're not removing and hauling materials in and out that they've already invested in. We can extend the life of pavements with the materials that are already there in place. Can help reduce those maintenance costs by we're addressing cracking issues, or we're addressing the distresses in the pavement all in place and building solid structural foundation layers for our overlays. We've demonstrated that we can achieve really good, smooth pavements for our traveling public, and we're going to continue to track and monitor the projects that I've talked about today. It's a feel-good story. We're reducing our carbon emission. We're reducing our footprint. And we're reusing materials, and we're reducing the demand for virgin materials on a lot of these projects. So just some final thoughts there on the recycling technologies in general.
Thank you everyone for joining us today, and thank you especially to Jason Walensky and FHWA for putting together today's presentation. A copy of the recorded presentation will be sent out via email in the next few days and will also be posted on roadresource.org. Our next webinar in the series, which will be on tack coats and fog seals, will be given by Jason Deep and Kevin McGumpy on October 15th. To register, you can go to roadresource.org. We also encourage attendees of today's webinar to register for the 2020 ERA virtual semi-annual meeting coming up from October 27th to 29th. The meeting is free to all ERA members and government attendees. To learn more about that, you can visit era.org.
Thanks, Ann.
And that
Lastly,
does conclude our... Go ahead, Jason.
Yeah, lastly, I'd like to give a couple minutes to talk about an evaluation, and the presentations are available on the file share pod on the left-hand side. But I ask folks to please go through the evaluation and provide us some feedback. We use this feedback for future webinars, and this information is very useful to us, so please take the time and go through it. And when you go through it, use the little arrow with a little line on the right-hand side to go through them. There's only 7 or 8 of them. They're pretty straightforward. I ask you to take the time to go through them. With that, Jason, we'll try to go through some of these chat questions. We only have 4 minutes, but like I said at the beginning of the webinar, we will post all these questions and responses along with the presentation material today. We'll send that out to everyone, and we'll be able to provide that. So, Jason, let's go up and see what are some of the questions that we have here.
So I noticed one about returning traffic to the CIR mat during construction.
Okay.
I saw that topic, and generally here in our area, we normally put traffic on it as soon as we can. A lot of our roads are open to local traffic or somewhat reduced traffic, and with the engineered emulsion packages that we see here in the Midwest, that we're putting traffic on them as soon as they're compacted, and then they're being trafficked, that night and next days until the surface overlay is applied.
Jason, another question from Greg is, do you have a reference for the 0.3 to 0.4 structural coefficients for these methods?
So I think the 0.3 is a number that is recognized by ERA. And Jason, I know you and I talked about some of the information coming out of NCAT, and I can't think of the other study now. The stuff from Virginia might suggest a little bit higher numbers than the 0.35 or closer to a 0.4 number.
I agree, Jason. A lot of the work that Brian did, and there's some paperwork on that we can provide further references on. But a lot of that work, Brian has some updated numbers that we can share. Our good old friend Vincent Ellison had a question. When using a standard HMA paver, do you recommend using a hopper insert, and why?
That's a really great question, Vince. I've seen some contractors use the insert, and I think it depends on material management, a lot on the depth, the width of the cut, how much material that we're anticipating to get through the hopper. It might be a little bit on the contractor's comfort level with the material as well. I've only seen it on a few jobs. Yep, go ahead.
Sorry to interrupt you. We have 1 minute left remaining. We want to take this time to thank everybody for participating. We'll get your questions answered. And any final thoughts, Jason?
Just really appreciate everybody's time this afternoon. I hope we all learned something valuable, and we're always here to help answer questions, because I think these are really great tools to help reconstruct and rehabilitate all of our roadway networks. So thank you all very much.
Thank you, Jason. And that concludes our webinar today. We look forward to you participating next month. Have a great day.
Again, that does conclude our conference for today. Thank you for your participation and for using AT&T teleconference service.